Okay, let's get going. Yeah. No, we didn't do it. I didn't. Not this time.
And nobody's invited you.
Well, yeah, we'll figure out something. Yeah. Okay. Hello, everyone. Please take a seat. Please take a seat and let's get going. Okay. Welcome, everyone, to beautiful British Columbia and the first OAUTH session. This is the not well. As you know, everything that we do at the IETF is governed by the not well. So if you're not familiar with this, please make sure you get familiar with this. Meeting tips. I think I need to mute myself now. I'm good here. Make sure, please, to sign into the session via a data tracker. This allows us to know how many people are here and allows you to know to join the queue. Do you have anything here? No. Is this? Did you join the session? No. Okay. Yeah, not sure. And if you're remote, please make sure to your audio and video is off unless you wanna speak up. A quick update, we have 3 documents that are in workgroup consensus. The protected resource metadata, we actually, I am the shepherd for that document, so I did a review and I've started the write-up there, and I think next week we should be able to push it to Deb. I don't know if Deb is here. But yeah, hopefully next week we'll be able to ship it. The other 2, Hannes and I will take care of them later in the coming few weeks. The other one is we have the RFC editor queue. We have 2 documents. The last one was waiting for the security BCP, so now hopefully both of them will be published in the coming, I don't know, few weeks. You never know with the RFC editor, okay? So our agenda for today, we have SD JOT, Christina and Brian will talk about that. And then Brian will talk about SD JOT VC. A transaction token, I think George and Atul will be talking about this, okay? And then Aaron will be talking about OAuth first-party apps and client ID metadata. And the last one, Peter will have about 10 minutes to talk about encrypted authorization response. We had to shuffle the agenda a little bit. We had Pika here first initially, but we moved that to Friday. Now, we still have a meeting tomorrow and another one on Friday, so just as a reminder. So that's it for the agenda. Any questions, comments, agenda bashing?
Yeah, Mike Prorock is taking meeting minutes. Thank you, Mike. If someone else can also add notes or keep track of the meeting minutes, please do so to fill in gaps, because it's sometimes difficult to sort of follow the intense discussions. Awesome. The link to the meeting minutes is on the agenda page. Just
yeah.
Yeah, you just go and there's.
Yes. Okay, Christina or Brian or both?
15 minutes?
You have 20 minutes, I think.
20? Okay.
Yeah.
Hi, everyone. I'm Christina here to talk about this DJOT. First things first, small affiliation change. I did start an associate professorship at KU University, so this work is being sponsored by KU University. Next slide, please. And kudos to brilliant background by Brian Campbell. Next slide. So we are sticking to our pretty much common agenda for digital presentations now. I'll start with quick overview, refresher, what it is, go through changes from last time, open issues, and next steps. Just to show in the room, how many people do not know how a digital works? Like never seen, never heard. Okay, great news. So I'll go very quickly over the first part then. Okay, next slide, please. So in a nutshell, we are enabling selective disclosure of claims within a JOT by when the JOT itself gets protected, the issuer is protecting the hashes, non-reversible hashes of OAUTH data, and the data is sent alongside. So just removing the data out of the initial SAT does not impact the issuer's signature. So that allows for selective disclosures in a nutshell. And yes, it does assumes three-party model kind of where there's an issuer with DJOT who issues it, there's the holder who gets it, and the holder who presents it to the verifier. And we have been saying it from the very beginning, but our motto has been simplicity is a feature. So the goal is really try to make it as simple and easy for implementers as possible. Next slide, please. This is it. Please parse it. But jokes aside, you probably see a lot of new characters or last remaining character that wasn't used, which is tilde. The first three strings dot separated is JWS, and those thingies after connected using tilde is something we call disclosures. So basically, this is the whole string that holder would get from the issuer. Next slide. And the payload, so this is decoded header, payload, and the signature. So in the payload, you would have an array of strings, and each string is a hash of an array, which, base 64 your encoded array, which contains a salt, claim name, and claim value in that order. So this array
Microphone.
do I get to be like a singer? So basically an array gets encoded and gets hashed. Next slide, please. So if you were trying to disclose only one of those, you select disclosure that matches that hash. And next slide, you would send only that disclosure. So the previous long string was what got issued. This string is what's being presented. So you see there are like much less green parts in this one. So this is a case where user decided to disclose only part of it. Next slide, please. Okay, kudos to Richard F. Nord Barnes, who I don't think is in the room. A slight update in terminology. So we are now clearly differentiating. So a thing that gets issued, that we're calling as DJOT now, and the thing that gets presented with key binding, we're calling as D-JOT plus KB. So this is the thing which gets presented when the key binding is needed. So in a DJOT spec itself, we're leaving it open whether key binding is required or not. So in this case, to the string that we saw on the previous slide, when users selected was trying to disclose, users adding another JOT, which is something we're calling key binding JOT, which proves possession of the cryptographic key material, which is in the JOT itself. Next slide, please. So that was a quick overview. hopefully not too quick. So last ITF, since last ITF Brisbane, we published two versions, 9 and 10. And again, kudos to an amazing background from Brian Campbell. Next slide, please. So what's new in -09? I already mentioned it, but we're clearly distinguishing SD-JOT from SD-JOT plus KB. Thanks a lot to, again, Richard for working with us on that. And that kind of unblocked a lot of other things. So second point is, it's been NAT issues. NAT's an issue that has been open for a long time, but we did provide ABNF notation for SD-JOT and all the other parts. The third part is what was needed for EIDAS implementation of SD-JOT, where some implementations need JDAS, which is JSON serialization, basically. And we updated the structure to reflect their feedback. Yeah, that's it. And then, yeah, we did clarify some things that came as an implementation feedback. So yeah, some sections got consolidated, clarified how examples are perceived. So yeah, the bottom 4 points are really about kind of editorial. And the bottom point is interesting. So before we were leaving it pretty open that any mechanism can be used for this key binding, and we made the language much, much stronger that like pretty much it has to be the confirmation claim that is used. Next slide, please. So that was 9, now to 10. Again, there was also Richard's feedback. We do have a feature of recursive disclosures, and we have been getting some questions around, how that works. So we added some clarifications to, hopefully stop getting those questions. And then editorial updates and fixes. Next slide, please. So in our GitHub right now, we have, when I was creating the slides, it was 2 issues, then Brian opened one more, so now we have 3, but they're all really editorial. So yeah, going to the next slide. So the question from the editors to the working group is, hopefully there will be no SD-JOT presentation in the next IETFs, meaning do we think the draft is ready for the working group last call?
Did people have a chance to review the latest version of this document? No. Which version is the last one? Do you remember?
10.
10. If you've reviewed the last version of 10, please raise your hand. Okay, 2 people, 3 maybe, 4, 5. Okay. Okay, so I think we need probably more. Sorry, somebody in the queue? Like you dropped? Okay. Was he raising hand? Okay. I think.
So by when will we have these 3 open issues resolved? Because then we could potentially just start a working group last call. We can't start a working group last call if there are open issues in the document. Like, is this something
Brian
you're going?
disagrees.
Wait.
They're editorial, and my hope is to consider them as part of last call feedback.
Oh, yeah.
Yeah.
All the open issues are editorial in nature, and my hope was to consider them as sort of rolled up underneath the umbrella of last call feedback.
Okay.
People on remote can't hear.
Which
Like Brian's most recent comment, Dean Zachs,
He went to the microphone.
he went to the mic after that, yes.
Dean saying remote attendees came here to speak.
Okay. Okay.
All right.
That's fine. Okay.
Brian just said that editorial comments,
Okay.
editors are hoping to address as the working group last call feedback.
Okay. So it seems that few people reviewed the document, and I think, honestly, and I think we should start a work group last call and just make sure that people review the document and get it going, right? So if as long as these open issues are just editorial, I think we should be okay. So we'll do that next week, okay? Watson.
I think this work is actively harmful to end user privacy. You know, we're saying that you have these tokens, and our discussion of the privacy impacts is really, I think, in the draft still underselling the key point, which is it's the sum total of information you ever show, as well as the fact that where you showed it is completely visible to everybody.
Watson, do you want to get closer to the mic and repeat
yes.
that again?
Sorry, I think, can people hear me in the, let me turn up the.
Yeah, it's difficult here in the room. I think maybe.
You know, I've heard, can people in the Meet Echo hear me?
Yeah. So do you want maybe write that comment as a like in the chat there? That would be helpful.
Let me. Okay. What is going on? Yeah, I'll do that.
Okay. Meanwhile, anybody else has any comments, questions, any concerns? John.
I'll just preemptively say that this is far more privacy preserving than non-selective disclosure JOTs. What a surprise. That the zero knowledge proof mechanisms, while being attractive, are years from potentially being deployable. If we actually want to allow some sort of selective disclosure meaningfully in mobile driver's licenses and European EID documents, this is our last best hope, because we actually know how to secure the keys in hardware storage and do the sort of traditional cryptography, which we have yet to, with all due deference to the JWP folks that come for the next meeting, that's still a work in progress. So if we want to plausibly do selective disclosure, this is our best alternative, and we should continue progressing it.
Awesome.
Thank you, John.
Go ahead. Thanks, John. I think somebody else in the queue. Mike.
Mike Barak here. I'm going to strongly concur with Mr. Bradley. Having evaluated a lot of these options and run a bunch of tests, this is at least available today, working, and prevents disclosure. Like, it provides the ability to properly minimize data, right? That's a good thing. That's a desirable property, and we can use it today. So I'm a big fan of this work proceeding.
Thank you, Mike.
We have issues. All participants in the room. Sure. Okay. Yeah, I think we're going to start that. Okay. Thanks, Christina. We'll start the work group last call next week. Okay. Thanks,
Thanks, everyone.
Yeah. Brian. You want control or? Okay. Let me find you here.
Thank you, Dick. I encourage you to point out other errors as we go along. Copy paste is a bitch. Excuse me. Sorry, as they say in the local customs. All right, so I'm here today to talk about SD job-based verifiable credentials. Unfortunately, my co-authors, whom know quite a bit more about this than I do, are not here, so you get to listen to me today. But we are actually at IETF 120, and there is Vancouver there in the background, which is IETF 120. Thanks again, Vic.
Ryan, raise the mic.
Mike. I'm taller than Christina. How about that?
You can
Adjust it, or adjust
it out.
or adjust.
I'll hold it that way. Both hands. I don't know what to do with them anyway. Okay.
Gonna
So-
dance too?
I might not dance, but John Bradley is pretty strong in that area. So, hey, you've seen this before, sort of the rough agenda here. We're going to go a little bit of a refresher, talk about changes from last time, talk about open issues and questions in general, and discuss next steps. So the basic idea is we're describing a data format as well as validation and processing rules to express verifiable credentials, which is a term many are familiar with and lots of people like to use, with JSON payloads, both with and without selective disclosure based on the SD job format. And we just learned about the SD job format and learned that everybody was already familiar with it. So I won't go into a lot of detail on that, thankfully. This uses SD JOT as well as the well-established JOT content rules and extensibility model as a basis for representation of verifiable credentials in hopefully a way that real-world people can actually use and deploy. My thing goes on here. It does not at all in any way utilize the W3C's verifiable credentials data model, either version 1.1.1 or version 2.0 in progress. Thank you. There's now with less RDF. So a few examples, or an example that I'll go through here just quickly to kind of illustrate how this works. This shows how these pieces could be used theoretically, hypothetically, to represent the concept of the person identification data from the ARF, architectural and reference framework, using as the data of a German citizen. So we've got some input claims here. Basically, this is the data representation of this person's data in the, what I'm saying, personally identified data, or whatever it's called, sorry. But some of the main concepts here to look at are, we've got a bunch of claims, name, family name, birthday, document type, address, whatever, some pieces of age verification, which are just in JSON and are straight up Boolean values relative to the age. There's nothing super fancy going on here, but they can be individually selectively disclosed or not. And maybe sort of the key piece of this is a hypothetical URI representing this set of data as the verifiable credential type, the credential type, saying what's in here. And in this case, it's just an example, it's a URI. But the idea here is that this whole thing is typed with the VCC construct, and that says in turn what the actual data within the credential itself would look like. To make it selectively disclosable, you do some of the selectively disclosable stuff. Here's the whole thing encoded. It's not really that valuable to look at. But here is the payload after being sort of processed for selective disclosure. And you see, very similar to the example that Christina just showed, the SD underscore SD claim here showing the hashes of data that is contained in disclosures outside of the signature. Those are all the attributes or claims that have been redacted or made selectively disclosable in this document. You can see, for example, the age equal or over. These are the various age-related claims. Each one of those over 18, over 21, over whatever, have been individually redacted so that the holder of this document can choose one or more of those to reveal to the verifier as appropriate for the transaction, as well as a bunch of their other data. Notably, the confirmation is still here in clear. That's a key. That's probably all that's super relevant. This is the actual content of some of those claims. So each of those hashes maps directly to the encoded disclosure construct that's outside of the signature again. This is just some of them. So you'll see like the actual hash of it is what's in the document. And that's what's integrity protected. The content is encoded for transmittability and basically as sort of a cheap canonicalization algorithm. It's not actually canonicalizing, you're just encoding over it. And then the actual contents of that include a salt for non-reversibility, the actual name and value. Here's just showing some of them: name, birth date, street address, locality, and so forth. Sorry. And then the actual example of what would be presented would be the same content before. It's really hard to tell. I don't know why I thought this would be a good idea to put all this text in an example, but ultimately, this is the actual JOT itself. I didn't even color code it to make it easy to see, and it contains only a couple of the disclosures. Oh yeah, in this case, actually, it's only nationality and the age over or equal to 18 disclosures have actually been included in this. And then on top of that, there's a key binding JOT included, which is basically another signature with a nonce, an audience, an issued at time, and a hash over all the preceding content that more or less proves possession of the private key associated with the confirmation key that has a public key within the actual signed token itself. And then what is this? Oh, and then upon validation, after processing the whole thing, going through checking the integrity of those hashes against or finding them, and then replacing their values within the JSON of the document itself to produce the data that the verifier will have for further processing. This is sort of after the representation of the claims that are revealed and disclosed to the verifier itself. So what's happened since IETF 119? Weirdly, that's the same number that I had at the beginning of the slide. Thanks, Dick. In Brisbane, we've published an 04 just a couple of weeks ago. It's an opportunity to throw a picture in there. And what have we done in 04? So we updated a reference to the IETF status list draft document. We had an individual draft name in there. Now it's the working group adopted document. We introduced type metadata, but just the sort of beginnings of a structure around typing metadata for individual verifiable credential types. So beginning to introduce things like a schema document for the type, introducing display information, naming information, although that's not in here yet, it's coming, or a possibility to come, for the type. So rather than the actual raw claim names, you can reference names to display to an end user and give them locality information to display in different languages and so forth. So the beginning constructs of that are introduced in the latest draft, as well as actual JSON schema typing for that metadata, and with the anticipation that that metadata structure itself will be developed in subsequent drafts to include more relevant and useful information. Editorial changes, I always like to give myself credit for that. Updated the terminology to clarify digital signatures are one way to secure these VCs and their presentations. This is some, if I remember correctly, some sort of weasel wording around the fact that there are some folks that want to do sort of like a ECDH type key exchange up front and secure some of these pieces with a MAC for reasons. We're not describing how that works or how it could be done. We made sure that the language in the document itself didn't preclude that kind of application to algorithms, so that it would be legal for the types of entities that would want to do that can do it without being in direct violation of anything in RFC. Prospective RFC, excuse me. And then we reworked some key resolution validation rules around X5C, which is the certificate header chain in the document. We had some things that needed some rethinking, and hopefully it's much more clear, intuitive, and similar to how you would imagine validation rules would work when there's an X5C header in the document itself. Open issues. There's a lot of them. And actually, after sort of glancing over them, there's probably too many to go over in here. And it's a little bit out of hand. it needs some work and some clarity. That's really all I can say at this point.
So you don't want to discuss any of one of those right now? You have time.
Maybe. I was hoping you wouldn't say something like that, so I could just skip over it. You know,
It's up to you at the
yeah,
end,
maybe
right?
we'll come back to them.
Okay.
We are diligently working on this, but sometimes the issue tracker gets out of sync with the level of effort and ability to keep up with it in here. And I think we're kind of here there. It needs some TLC. I imagine we'll get to it. And all in all, I think things are in good shape, but we need some work. Some current work in progress. This is maybe more relevant, although just related to what I'd said before about extending what's available in the type metadata itself. There's a current open pull request that defines basically display and claim metadata so that really any of the parties involved in the transaction can evaluate the metadata independent of the document itself and give meaningful end user display information about it, including there's all kinds of stuff in there, both localized general display names and information about the credential itself, as well as individual pieces for each of the claims. Maybe notable, we are going with an approach where in order to identify the particular claim, like what claim this data is about, we're using an array of string values which basically identify the location within the document itself where this claim exists, which is, I don't know, seems sort of intuitive, but various different approaches to this have been thought about and fought about in a lot of different places. And this is a hope to do something simple that's easily implementable and doesn't bring in any dependencies like a JSON pointer or JSON path to do sort of the same construct, but with a lot of other, shall we say, baggage. I am currently fighting with Dr. Daniel Fett about whether something like the locale should be a key within a map of the JSON itself or an object to indicate it, or whether that should just sort of be a sub-property of the data itself. I'm obviously right about that, but we'll figure that out later.
So Brian, we have two people in the queue. Do you want to take questions now, or do you want to wait?
Please. Yeah,
Okay.
now's as good a time as any.
Okay, you're on.
He wants me to go first.
Okay,
I'm
go ahead,
mostly here to
John.
save you from needing to fill time by dancing or delegating that to me. So the metadata is interesting. I take it that none of the things that we're talking about as metadata are actually disclosed to the verifier. This is information that's for the purposes of the wallet processing or the holder processing.
I think it's like largely intended to be for the holder processing and functionality, but certainly the verifier might make use of it to do their own, display information or whatever, either upon request or upon verification. And it's not a secret from anybody. It'll be well known, resolvable from somewhere.
So I guess that's a question:
does it scare you from privacy?
Well,
no.
Yes,
Go
because
ahead.
it may actually disclose what claims are available, et cetera. And so
Absolutely.
there may be some privacy leakage. There may be some reasons why you might not want to disclose that, or it might not be ideal to disclose that to the verifier. The other question, so one of the problems that we're ignoring about wallet interoperability is around the issuer expressing a policy to the wallet, as in I'm the German government and I only want the wallet to disclose these claims to people that have the appropriate QWAC issued by a German verified issuer, which is a real but twisted thing. So it will, as people develop these ecosystems, if we want interoperable wallets, right now, the European Commission kind of thinks of things as, well, if you want to have a policy, build your own wallet, and then it will do that. But if we actually want interoperability, we probably need to express some sort of policy in an interoperable way from the issuer to the wallet. Is that metadata perhaps a way that we could communicate that to the wallet so the wallet would know, yes, for California DMV, anyone can ask for over 18, but if you want the person's address, perhaps you have to be on a trust list someplace.
There's
So the
there's
question
a-
is, would
maybe.
the metadata perhaps be a way to annotate that sort of policy information for the wallet to consume?
Perhaps, yes. It's not actively on the list of things we're planning to add to it, but I am well aware that there's an interest in expressing that sort of policy somewhere, as well as some debate about the appropriateness of where that policy might live. I think I'm aligned with you that metadata is maybe a good place for it rather than embedded in the credential itself. I don't know, actually. So
We
yes.
need to find.
Yes, maybe. Yes, maybe.
Yes, so I think we need to figure that out, and maybe using this document, see if people scream.
I could definitely be amenable to that.
Okay.
I think it's probably the right place. Back to your previous comment, there are probably cases where the privacy of what the whole credential may or may not contain are relevant and meaningful. You don't have to use this mechanism for that. You could hide it. And in most cases, I think the actual potential content of any credential is going to be pretty well known anyway. So it's like, this is just describing it in a way that's meaningful. And if you have more, I don't know, maybe I'm not thinking about it hard enough, but
I think that some sort of privacy analysis needs to, we should at least,
you're probably right.
so, you know, I'm one of the most anti-privacy people around,
Yeah.
but I will observe that we need to have an answer when people do look at this and say, well, you're leaking. So we need to at least, if it isn't a problem, we need to understand and explain why it isn't a problem.
Fair enough.
Thanks, John. You're on.
You're on, Chef. So more or less in the same area, but even simpler. So I have a VC with an SDJ in it. I go to a bar here. I'm being asked whether I'm over 21. Then I go to a bar in some other country and I'm being asked whether I'm over 18. Do we have a protocol for the bar to actually express what they want from me, even before policy? Yes?
Well,
Christina, do you want to go to the mic?
Hi, Christina. So SDJ and SDJ are kind of protocol agnostic, meaning the transfer protocol, but like, for example, OpenID for verifiable presentations protocol that is widely being used right now to request these things, it does have something that we call query language that allows to request, like, give me, you know, like only this claim. So yeah, we have that. And we, sorry if it's too much extra information, but we are introducing an updated, hopefully much better query language in OpenID for VP, which is not presentation exchange. So yeah, we are actively working on that.
maybe just to clarify, this is literally just the token format itself and the constructs, I guess, plus metadata and so forth. There is work in the collective we around requesting, presenting, even issuing and so forth, but that's not happening in the scope of this document or this working group for that matter.
So, okay, the subtext was the metadata probably needs to be aligned with this kind of query.
The subtext, yes.
Great point.
Yep.
So we actually have something like this already in the OpenID for verifiable credentials protocols. And that's where I and Dr. Daniel Fed do argue, where I think that those needs to be somewhat better aligned. But because those protocols do define something very, very similar to that. But A, that's probably not the only protocol people want to use. And two, We did try to introduce these changes, but the protocol is being widely used right now and people did not want big breaking changes. So long story short, we are doing our best to align them, but with mixed success so far.
Thank you, Christina.
Queue is cleared. May I proceed?
Yeah.
I'm being told I have 26 seconds. Is that?
Yeah, like you can go a little bit further.
Okay. So media types. Yeah, if you know, you know. So the term verifiable credential was coined and sort of popularized, I'm not sure of the right terminology, within the W3C standards organization for a variety of reasons that I won't go into and don't fully appreciate. There has been an interest in defining something a little bit simpler, a little bit easier to use, at least from the perspective of people involved in the work, and doing so within the IETF. For better or worse, that work, this work here, has used the term verifiable credential as well, because it has some meaning to people. So it seemed straightforward to sort of reuse the terminology in a way that conveys what's going on to people familiar with the term. Until very recently, the W3C Verifiable Credentials Working Group was planning on requesting this set of media types at the top here, which were a number of media types that were intended to convey sort of complex, layered, structured processing rules around their credentials, namely that it's a verifiable credential or presentation using JSON LD and then potentially secured through means of a JOT, an SD JOT, or a COSE signature, or COSE signature. I'm not sure how to pronounce that, apologies. As well as a number of structured suffices to be registered as well that helped convey that information. There was some disagreement within the media type working group as to the okayness of multiple suffixes. I don't even know how to say it. And whether that's okay. The most recent conclusion, although I don't think it's a final done and done, but is where we're at now, is that it's not okay, that it's not allowed. And so recently, that working group within the W3C requested and received registration of application VC and VP, and is hoping to also register VC plus JOT, typo, there should be a P there, a few others, and application VC plus SD JOT, which interestingly enough, hi Brent, is the same media type that SD JOT is currently using within its specification, and which a number of dependent down the line specifications have used, and a number of early interoperability, I'm not sure what the right terminology is, some early pilot programs within the EU are also using in production right now. So we have a bit of a fight, discussion, potential conflict coming around media types and their names. And although it's just a string, there are a lot of vested interests and interests. I'm having
Brian,
with words today.
Brian, we need
You
to
want me
wrap
to
it
shut
up.
up,
Yeah.
don't I don't know what to do about it. Here it is.
So, yeah, we have two people in the queue, so
There's
let
some
them.
people in the queue.
Yeah. So
Go
Ori.
ahead. I'm going to jump to the next slide though, because it's got a pretty picture.
Hi, Ori Steele, Art AD. The media type session for this IETF is Friday at the 1500 time slot. The document that previously was requesting multiple suffixes has in fact been modified to basically say don't do that. Everything you said regarding this being a problem is accurate. I stand with my AD hat on, ready to assist you in your exploration of media types and what they could mean for your work. It is a problem. We've got to sort this out. I'm looking forward to conversations with you throughout the rest of the week, but I just want to say, if you care about fixing this problem, you may need to show up to the media types group every now and then to provide guidance on their documents and help them progress some of this. And I'm happy to help facilitate that to the best of my ability.
I thought that was this, excuse me, this afternoon. Am I mistaken, or did the schedule change?
Oh, I'm looking at 1:20. Yeah, that's why I can't find it. Thank you. It's whatever time is about to be put in the chat. It's this afternoon, I guess. That's what I get for standing up at the mic as soon as I'm triggered by this.
Okay. Mike. Withdraw. Okay. That's it. Like,
That's all I
wrap it
got.
up.
I'm done.
Yeah.
Thank you, everyone.
Thanks, Brian. Okay, George. Oh, not this one. Come on. This one.
Should we do the slides?
Yeah.
You can hit that slide.
You want me? Okay, that's fine. Yeah, let me know.
All right. Sure. Go to the next one. So Tool and I are going to talk about transaction tokens and what we've done since IETF 119. Same location, different shot. If you were paying attention from last deck. Next slide. So let me ask a quick question here. How many people are not familiar with transaction tokens? This is like the third time we've been talking about them. A few people. All right. So let me give the 30-second. I left the intro slides out of this deck. Fundamentally, in most deployment architecture today, you have multiple workloads that need to handle something that needs to be done. And we tend to secure the communications from one workload to another workload. We don't tend to do anything in regards to the entire transaction. So this is about how can we potentially create a token that represents the work that needs to be done to complete this transaction, and it get passed through each of the workloads that needs to do the work. It's in addition to whatever sort of server to server kind of authentication or communication perspective that might be there. Lots of good properties. Happy to talk about it afterwards. The way I set up this deck is really just to sort of very quickly run through what the changes have been since IETF 119. So hopefully we'll go through this really fast, and then we have got like 3 slides for open questions. So that's kind of the plan here. So this one, PR73, for anybody who wants to go back and look, had to do with the fact that a transaction token is valid within a logical trust domain. You might have multiple ways that transaction tokens get issued, but logically they all form a single entity, and they're only valid within that logical trust domain. So we have this concept of a transaction token service, the thing that issues the tokens. And so one of those, one logical transaction token service for the trust domain. There'll be another talk tomorrow, is it, Brian, where we're talking about chaining across trust domains. So this is within a trust domain. Next slide. Yarn has raised a number of times issues with privacy considerations. Obviously, if you have got transaction details in a transaction token, that's private information. Don't log it. So we've updated the privacy consideration. We added a privacy considerations and have added text there. More could probably be added. So we would love feedback from anybody who reads the spec and feels like that needs, please contribute text. There are ways to address logging things that allow you to sort of track what's happening without exposing any of the data. Those can be applied. Next slide. We have the concept that there may be a workload that needs to get a new a transaction token that has a slightly different context. but maybe it needs to restrict some mechanisms in the token itself. So we added clarifications about what can be modified and what can't be modified. Obviously, you don't want the subject of the transaction token or the audience, which represents that logical trust domain, to be changed. We didn't explicitly call that out. So those kinds of changes were made for replacement transaction tokens. Next slide. Added some clarifications around the fact that the audience claim represents this trust domain, and it effectively the value of the audience claim should be the unique identifier that represents the trust domain. For other people that are thinking about this, we also added, it may come up later, so we can skip it when we get there. The subject of the transaction token is identified within the context of the audience. So when you think about an ID token, the subject is in the context of the issuer. In a transaction token, the subject is in the context of the audience. Next slide. So transaction tokens were intended to support both external, requests coming into your network from an external environment or client, as well as requests that are initiated within your trust domain. So you can think about it internal versus external. In one way, generally an external transaction is going to have a token associated with it already. Maybe that's a SAML assertion. Maybe that's an OAuth access token. And effectively you're exchanging that access token for a transaction token. And there's all sorts of good properties that we've talked about in the past about the ability to effectively downscope, where your inbound token may have some broad scope and what you're trying to do is very specific. You can put that very specific purpose into the transaction token. However, if it's internal, how do you represent the work that needs to be done? And so we've explicitly added the ability to send in as the subject token a self-signed JWT. I think we have a issue about this, but what we've added to the spec itself is basically additional clarifications about how you would, do an internal initiated ability to get a transaction token for this workload. Next slide. Added a tool's done a bunch of work to add registry and HTTP header work. The expectation here is that the transaction token will be carried in a new HTTP header. Brian's been super helpful in helping us get the text right, and we may need to do more work there. So super appreciate Brian and his sort of verification of what's been done so far. But these are just basically some of the strings that we clarified within this particular update to the spec. Next slide. We added basically a subsection for the AZD claim, which is the authorization details, and to basically add clarification text about how it's different from the request context claim. And then adjusted the examples to match. Next slide. Basically, to be expected, but we added explicit text that, if you're doing a replacement transaction token, you can't increase the scope of what was in the original transaction token. There's probably some nuance here that we have to adjust and think about. So would love comments or feedback in that regard, because I think there may be times where the replacement transaction token may, orthogonally change the scope, and that probably is okay, but how you know whether it's okay or not is of interest. Brian, did you have a comment about one of these slides?
Yeah, I'm sorry. On the,
on the
last slide, you don't even need to go back, but it struck me again that the name authorization details is literally the same name of the claim from RAR.
Yes.
And that I find that confusing every time I hear it. So I don't know. Speaking of name fights, I don't know. I don't have a better name, but maybe thinking about a different name would be helpful for
Yeah, so
folks
I would
out
love
there.
feedback on that. It was intentionally the same name. Because
That's terrifying.
um, because right when you think about RAR and you think about the inbound RAR request and the experts right behind you, an inbound RAR request.
He wrote more of it.
You wrote the parts you don't like.
Okay.
Accurate.
Was right. You're basically, at least the way I've seen it used, you basically were defining what it was that was specific about this the authorization requirements that were specific, the things that should be effectively immutable that make their way into the access token, so the access token can only do those things. And this was effectively to be a container that describes the immutable aspects of the transaction. I'm not too particular, right? If we can come up with a better name, that's fine. But that was, for me, the semantics were very similar when I thought about it, hence using that to start with.
Little brain's going. So one of the main ideas of RAR was about conveying some of that information, but really it talks about different pieces. It's really about client to authorization server and trying to codify how that link can be communicated. And so maybe I need to look again at what the draft's doing, but it feels like maybe it should either reuse the claim directly if that's the intent, or use a different name if it is a different intent. At least I find it confusing,
Okay.
having not specifically read the details of the latest draft, so I apologize for that. But
No worries.
Hi, Justin Richer. Similar concerns as Brian in terms of the alignment of this. If it's going to be a similar enough name, it really should just reuse the syntax. I don't think that that's the intent of this, is to reuse the syntax. And so calling it something like transaction context instead of request context, I think might make all of these kind of problems go away. I would, however, encourage the authors to specify a way to specifically include a RAR authorization details object structure, that array structure that RAR defines. Give us a common place to put that, the same way that we have a common place to put scope, because RAR from the beginning was always intended to be scope, but with more knobs to turn.
Okay. Just a clarification. Are you talking about the request context field, or?
I am not.
Okay.
I said transaction context in addition to request context. I may have also said something else that was incorrect, so sorry about that, if that's the case.
Okay, next slide. There was some concern that we got feedback around the TXN claim, which is basically a unique ID for this transaction token. That in some contexts, some deployments, they might not be able to use their existing identifiers for how they do that and get them into this claim. So we basically just said that if you can't do that, make it N_A. It's still a required claim. It's not optional, but you can fill it in with a nothing. It's not recommended, but and I'm happy to take feedback that says you must put a real value in there as well. But that was, we're responding to feedback and issues.
Justin Richer, isn't this just null with extra steps? Or optional with extra steps? I'm wondering what the extra steps actually.
From a processing perspective, I mean, you can do it multiple ways, but I would personally, I prefer to have, about, something that explicitly says, I'm not going to give you a value in it, as opposed to just sort of like leaving it non-existent in the transaction token.
Okay. The error case here is that a naive processor ends up lumping together a bunch of transactions under NA. And if you look at any record system that like dumps everything with a value of null in a field, it's the same problem. I think this is a little bit bigger foot gun.
We sort of took this a little bit from the the token exchange spec
Mhm.
did something similar in some contexts. But if the feedback is switch it from NA to null or to
Or
open
something.
paren, null, close paren, which is what Apple does or whatever, I don't. Fine, right? Just
Right. Yeah.
you
It's
can take
just,
feedback on that.
this just feels like a hidden foot gun because it's a string, because it looks like a valid value, but there's semantics within the value itself that you additionally have to process. That's what worries me about this particular approach.
I guess I'm not sure why are there additional semantics.
Because I have to not only say take the transaction claim and that value and just treat that as the value, I now have to look at the value and see if it's a specific value before I can continue processing it. Whereas previously, I either take the transaction value, or if it's not there, I do something else. That's a much simpler code break than this, and a lot harder to miss.
Except for I have to do the optionality that says
You got to do it. You're not getting rid of the optionality. That's what I'm saying. This hides it in a way that I think is dangerous.
I'm saying the logic to basically say, when I parse this, I then have to go check to see whether the claim is present or not. I'm doing the same level of checks regardless.
Right.
It's just I'm doing them in different places.
But maybe you call it a statistically unique identifier and just put a 128-bit random number in there, and then you're done, and you have a unique identifier for everyone.
That would also work. You hopefully would not have any collisions in that context, Hannes.
You would
Go ahead,
not.
Brian.
Just the NA and token exchange is, I put that there, I'm sorry for it, but it was there to work around a constraint of a specification that extended, and it didn't have the ability to make optional, and so it's pretty ugly, but in this case, you are controlling both constructs, so I wouldn't take that as a reason to do it this way.
So would love feedback from the community on, where we want to go. To me, there's a huge amount of value for me in having a valid transaction identifier in the token, and not having one seems not ideal. So I would take, I'd probably prefer Hannes's suggestion of putting something in there that is unique and, even if it's unrelated, but anyway, please, issue or the OAuth listserv, we'd love feedback. I'm assuming, Brian, you don't have another comment. Sorry.
No.
Next slide.
Yeah.
Because we're.
Yeah, you can.
Anyway, updated perk pin, go to the next slide. And the HTTP header registration. All right, next slide. So we've talked a little bit about this, but I would love feedback, and we talked about this as a team, right? We would love more feedback on these use cases where, some process within the system. I'll give you a classic example. You have an inbound mail delivery server, right? So it's getting inbound SMTP requests, and that server wants to get a transaction token to pass with the delivery of all the workloads that have to happen in order to deliver that piece of mail into the user's mailbox, right? And you want to ensure that, the only thing that can happen across this set of workloads is effectively delivery of content into an inbox. You don't want it to turn into, how do I read the person's email, right, from their inbox, right? So there's a lot of value in having a transaction token in that context, right? What should that inbound email server use as its subject token into the transaction token server in order to obtain the appropriate transaction token for that use case? What we have specified right now is use the self-signed JOT. That there could be other ways of doing that. So we definitely would love some feedback around that aspect of use cases within the transaction token spec. Joseph.
Does it have to be a self-signed JOT? Like, would there be a case where you would want this to come from, this subject to come from somebody else in that?
No, it doesn't have to. Hence, we're for these one of the options is you just leave this completely out of scope from a specification perspective and just say this transaction token service is serving this trust domain, and within that trust domain, it's willing to accept whatever it wants in the subject token. We have both a subject token parameter and a subject token type parameter. So that could be defined locally for that deployment. And we can just say within the spec, how you do that's out of scope, but the transaction tokens are intended to solve that use case. That's an option, right? This was a way of saying, if you want to do it in this particular way, you can. But no, there isn't anything that is necessarily super valuable about having it self-signed, other than obviously if you have a signed JWT, you get some level of integrity protection, across the API call.
Right. So, I mean, it seems to be a self-sign could be useful in many cases, right? So I think it's kind of good to outline that, and maybe, I don't know, I'd have to look at it a little bit more and think about it, but maybe there are trade-offs, between doing self-signed and having some authority sign it or something, right? And then there may be a security trade-off there that we can describe in the document. So that's
Okay.
Okay, thanks, Joe.
Let's go to the next. There's two more questions that we can.
You can talk to them, but
Yeah.
we're not gonna take.
Yeah, we don't have any time to cover these, but this was one of them had to do with the objects that contain either request context claims or the transaction or the authorization level claims. Do we need like a full IANA registry for these, or can they, because they tend to be very specific, can we leave them effectively out of scope? So please, this is an open issue. Please add thoughts here. And then there was a question around metadata, like should we add some level of discovery mechanism for the transaction token service, or is it enough deployment specific that any of the entities within that trust domain would know where it is, and therefore additional metadata isn't required? So again, please, we'd love feedback on these two issues and any others that you thought of today.
Yaron, do you have a quick comment there?
Very, very quick. I think self-signed JOTs are a major foot gun, similar to non-algorithms. I would love to see them go and replaced by a simple JSON object.
Thanks, Yaron. Okay, George, that's all. Thank you, guys. Aaron. Let me try to pass the thing. Hold on. You wanna
I have
share
no
the
idea if my
slides?
voice
Okay.
is going to work.
Okay.
There we go.
Hold on.
Okay. Do I get slides?
I thought you want to share it. Do you want me to share it and then pass it to you?
I would like to control them. Yes.
Yeah, yeah. Okay. Share slides.
There we go. Thank
Okay,
you.
good.
Okay. Wow.
Go.
I do not sound normal. I'm sorry. I'm losing my voice, apparently. Too much yelling on the water last night with Tim. We had some fun on some little pedal boats. It was fun. Okay. First, going to talk about OAuth for first-party apps. So this is, I don't have an agenda slide. I should start doing that, but it's roughly the same plan of quick recap of what this is about. But I'm going to keep it really quick because this is now, I think, fourth or fifth time we've talked about this here. Essentially, this is a draft that addresses the problem of developers of first-party apps, in particular, usually mobile apps, want a better user experience for their users than what currently is recommended by the best practices for OAuth for native apps, which gives you this. Instead of following recommendations, people are finding very creative workarounds to avoid popping up a web browser, and some of these workarounds are slightly terrifying. And we would like to provide people with a better option and a standard option, and one where we can all properly agree on things like security considerations of the solution. One of the goals of this particular draft is to make it fit in with the rest of the OAuth building blocks as much as possible, mirroring how the web authorization code flow works, but leaving, similar to the web authorization code flow, leaving the specifics of how the user actually authenticates up to implementations out of this core framework. So just like the authorization code flow does not say, now put up a password form and ask the user for their password, we're doing the same thing in this draft. So this is kind of an illustration of the flow where the blue parts are the part in scope of the draft, and the part in the middle is the implementation specific. This, I guess I'm missing a line on this, which is the time axis, which is from the left to the right of the slide. But essentially the client starts the flow, and then it goes back and forth with the authorization server to collect whatever it needs from the user to authenticate them for the context of the request, and then eventually results in an authorization code, which the app can then take to the existing token endpoint. So this is done with a new endpoint called the authorization challenge endpoint. Essentially, it is accepting any parameters that would have been sent in a query string to the authorization endpoint or in a post to the PAR endpoint. And it accepts a post from the client to start and possibly continue the sequence. The response from this is going to either be, we're done, you got an authorization code, or we can't fulfill this directly and we need you to go to the web and finish the flow on the web, or whatever else you want to do for your implementation. Also importantly, this is not meant to be the only endpoint that the app uses throughout the flow, which again is similar to the web authorization flow, where the client starts the flow at the authorization endpoint, but then that authorization endpoint might redirect the user to 5 other endpoints, or even off of the server completely before finally reissuing the authorization code. So we're just trying to keep it the same here. So changes since last time. Some work around Depop binding to make it work with Depop. We have a little optimization of actually using PAR as an optimization for this method of actually when you need to go out to the web. Basically it meant that redirect to web instruction turned into an error response. And the request URI moved to the error response, which then looks a lot like PAR. So hopefully if you are using PAR, then this is, again, kind of just a natural fit. If your implementation knows that it will frequently be redirecting to the web, there's another optimization you can do, which is including a Pixie code challenge in that first request. That way you can skip sort of asking for it again. We also, thanks to Brian for clarification that the follow-up requests after this endpoint do not need to be form encoded. They can absolutely be whatever you want, and they can be at any endpoint that you want. We also clarified that this auth session value, which is essentially meant to tie in all of the requests that happen until an authorization code is returned, is meant to be only on that device. It's not meant to hop over to the web or be shared across devices. It is meant to be temporary. It's meant to live from the point of starting the flow to the point the authorization code is issued. Okay, so that's all great. One of the other things that happened since the last meeting is there's been a lot of interest in this, and way more than I actually thought, and farther along than I thought. So Microsoft has public docs now for this API. This is based on a slightly earlier version of the draft, but it is inspired by the draft and looks similar to it. Yahoo had a presentation at Identiverse just a couple months ago. Is that right? I don't know how time works. Yeah, May. describing their research into using this for their own apps. Auth0 at Okta has an in-progress implementation now. I don't have any docs to share of that, unfortunately, yet, but it is an in-progress implementation now as well. And there's a public issue on the Keycloak repo from people showing that there is interest in building it in there as well. So I think that's pretty exciting.
Yeah, I think there is WSO2 also. They have an
Oh,
implementation.
I forgot to add that one. Thanks. Yep. So that's the update, quick update. And essentially, this is the next steps, I think.
Yeah.
I think this is ready for a working group adoption call.
Yeah.
The other sort of large pending item is, I do think it would be useful to have an explicitly defined method for when the user interaction mode is passkeys. How does that work so that at least that one can be standardized? And we still leave everything else up if you want to do other things in addition to that, but at least for passkeys, we should have a standardized way to do that. So Tim has been working on that already, and it's in a pending PR now as well.
Awesome. Okay, so we're gonna ask for a call for adoption right now. So I'm gonna ship that question right now. What? Number are still rolling, so let's give people a few more minutes, a few more seconds.
Yeah.
Yeah. Okay. Okay. Looks great. I'm gonna end it here. Hold on. Great. I think we have strong
Thank you.
support here, so it's adopted. So thank you for that. Yeah. Deb.
Of course, we will repeat it.
Yeah, absolutely. So again, this is just
You're gonna follow
to
it up on the list, right?
go
You're
ahead.
gonna follow it up on the list, right?
Yeah, absolutely. Yes. Okay.
Okay, so just for my notes, then you're going to follow that up on the mailing
The
list.
mailing list, yeah.
And
Next
then
week.
Next
As
week,
always.
as
Yep,
always.
as always,
And
yeah.
then the next step would be to publish as is a revised name
Yep.
version.
With the
Great.
0 version.
Okay, thank you.
Okay. Now-
Go ahead.
Yeah, go ahead.
On the previous draft, on the first party apps, yeah. So this has emerged as a potentially very useful mechanism in the context of verifiable credentials world for presentation of a credential during issuance for authorization code flow, where the issuer wants to turn around and ask the user to present something. So if the first authorization request is a redirect, it messes up the user experience. So a lot of people whom I redirected to look at this draft said that it's potentially helpful, but at the same time, it is a first party intended mechanism. So I apologize for throwing this at you like this. So maybe you should follow up offline, but do you think that your draft right now might be something helpful for that use case?
It was a very, very clear goal from the beginning to only define this for first party applications.
Okay.
It is obviously possible that the same mechanism works in a third party app because ultimately it's just talking about, how bits are moving across the wire. But there's a lot of text in there that describes why you don't want to do this for third-party applications and all the things around that. And really the context of the draft is set with that in mind. So I think if there was going to be a use of this for this kind of third-party scenario, it would be best as a separate draft
Okay.
so that it can properly discuss the security considerations of that scenario.
Okay, I'll look into the considerations you already have. Thanks.
Okay. George, you have a comment?
So I think, Christina, it's a really interesting question and happy to have a conversation about it. I think that the nuance here is that when you think about presenting credentials, those credentials in the current world, username, password, some other thing, that's stuff you don't want some random mobile app out there to see. In the context of using the client attestation stuff that we're talking about later this week with an app and some holder binding and some other stuff, right? And the fact that you're presenting a verifiable credential that's protected in some way, that, right, if the credential itself is protected, then that may be different. So agree with Aaron, right? We might need to see, is there a way that we could extend this spec to cover these things, but probably useful at least right now to do it as separate work. But I'd love to be part of those discussions.
Okay. Tony?
Maybe this is a question more for Tim, but why just passkeys? Why not? Okay.
Yeah, so I think if that's a top of mind use case, you should look at these together. The way, essentially, if you look at the WebAuthn extension, right now it's in the spec, but it's just which parameters do you have to pass for this to be successful. There's no reason why that couldn't be inputs to like the digital credentials API. And I think for a VC, since it's intended to be used cross-domain, I don't know if there's actually any concerns there because you're presenting your credential. I think we should think about that in the context of, yeah, that was just the first use case. Yeah. Taken out by my own bag. So in the link he added, it's a separate link because I couldn't merge it. I forget what happened, but there's essentially a section on WebAuthn.
I couldn't hear that.
Is Tim's work in a pull request?
Tim's work is in a pull request right now. Yeah. Yeah.
Okay.
Okay.
Next one.
Next topic. Great. Thanks. Okay. Continuing the tradition of photos from the area this was from last night, about 300 feet in the air. Okay. Client ID metadata document. This is something totally new. First time presenting this here. Co-authored this with Amelia, who is actually online. So going to give you a description of what this is for and also the sort of status of the implementation. Okay, baseline scene setting, OAuth client registration. This is a thing that has to happen. Clients register with the authorization server to establish things like where it's okay to redirect the user. What is the client's name? What is the logo to show in a consent screen? What scopes does it support? What authentication methods does it use? There's a whole handful of properties that get registered. Currently, registration happens either out of band. The developer goes to a website of a product of an authorization server, manually enters this information. There is also a couple other different ways it can happen, but in some cases, this is actually not possible to do, in particular when the developer of the client does not have a relationship with the authorization server being used. In particular, things like an open source chat app that connects to a self-hosted chat server. Apps that connect to things like Mastodon. There is no central server that a developer can register this information in. Okay, so you're probably thinking dynamic client registration, cool, this solves the problem. Client can show up and provide this information to the authorization server at runtime. It is a solution to the problem. However, in practice, it has turned out to be mostly unsuccessful for a couple of reasons. And again, it's specific. Did anybody else just hear that? Okay. So in particular, a couple of problems that have actually happened in in real life, if you want a play-by-play of the details, there's a link below that goes and you can read about people going back and forth, discovering and then solving and then rediscovering these kinds of issues. Primarily, it has to do with the fact that in this world, it is a like n times m problem of any number of clients showing up at any number of authorization servers with no prior relationship and trying to maintain the registration information from both sides. Clients having to remember which authorization servers they've registered and which credentials they've been assigned. What happens if the authorization server gets registrations from thousands of clients and then they want to prune ones that haven't been used in a year, and then that client actually wasn't really dead, and then it doesn't know that it's been pruned, so it's just a big mess of state management. And this often leads to just dead ends for the end user of like, my app doesn't work anymore, or why am I seeing 100 versions of this app in my security settings? Why does it look like I've authorized this app 100 times? It's the same app. So essentially, this is not really a feasible solution. There was a previously proposed solution presented a couple of IETFs ago about client discovery that defines a well-known endpoint for client metadata. This is very similar to this draft, but there's a couple of problems with this method that made it not really. When I went to go write this up, originally I asked Tobias if I could just steal his draft, and he was like, yeah, I'm not going to do anything with it. And I went to go do that and realized actually it's not going to work either because of the problems of using the .well-known pattern for this kind of thing. My favorite one being what happens when you have these kind of multi-tenant systems of hosting multiple clients on a domain or multiple tenants with multiple clients on a domain. It's a giant mess. Like, you know, one of these versions is what you kind of want to do, and then one is what you have to do according to the .well-known syntax. So it's the same problem that we have with authorization server metadata, how the reason it's different between OAuth and OpenID Connect. It also means that we can't actually host this document in a location that's different from the client's website, and doesn't really work for non-public apps, but that's, I don't know, maybe not the best example of this anyway, but essentially I wanted to start with this and then realized it wasn't going to end up working. So this draft is relatively short. Essentially what it says is pick a URL and take all the properties that you would have done a dynamic client registration request with, which are all defined in this IANA registry, and put those in a JSON file at that URL. And then use that URL as your client ID in an OAuth flow. So this is what it ends up looking like. You have, you know, all your OAuth parameters, and then client ID is this URL. At that URL is a JSON document, and the JSON document has to have a client ID parameter that matches the same URL that the document was fetched from. And then it can have all the other properties in there as well. There is an open question about whether the client URI should be a prefix of the client ID or whether the host name should match, things like that. If you're curious, chime in on issue number 10. There's some good arguments for both directions, I feel like, so it's an interesting discussion. So then it talks about, okay, so the idea is, here's the metadata at this URL. It's in the client ID parameter. This is the first time this client has shown up at an authorization server, so it should go fetch that data to display things to the user. Or it can just not if it doesn't want to, or it can validate the data and ignore values that it doesn't believe or trust or whatever. The point is that that information is available if the authorization server wants to use it for displaying to the end user in the consent screen. The other important part, though, is that that metadata does include redirect URIs, which is one of the security features of OAuth. So that is the list of URIs that is the only list that is allowed to be redirected to for that client. Another fun thing you could do is publish a JWKS URI, and now you can actually turn these into confidential clients with JWT authentication. And the metadata documents do have to be publicly accessible so that the authorization server can fetch them. Okay, so before we get to the questions, I'll see what people want to say in the queue.
Okay, David.
Just a little concern about the comment on, I think it was page 6, about showing the URI, the presence of things like the logo URI and client name, because I don't believe being able to get a JSON file hosted on a web server should be considered to be buy-in that that's an official client of whatever organization runs that web server. That's
I
kind
only
of the
heard about half
purpose
that,
of
David. I'm
yeah,
having a
that's
hard
kind of
time
the
hearing you
purpose
over
of
here.
sorry.
Yeah.
That's kind of the purpose of having it in .well known, is so that there can be a process, a single location for those types of metadata that are basically server level and thus could at least be inferred to be organization level.
Are you saying you want the logo URI to be at a .well-known path?
No, I'm saying that the difficulty with the approach of arbitrary URLs is that there is no world representable client identity. So there's a unique identity, but there is no way I can know for sure that this is an official client of webmention.io just on the basis of someone being able to put a JSON file on that website.
That is true, and that's essentially a unsolvable problem in the space, and it's an accepted risk in these kinds of deployments. There's not really anything, because this is not run by, there is no single registry of this information that is maintained by people who run the authorization servers. There is no, you're not going to get help by that by changing what path it's on. So it's just like, that's just the way it is.
Okay, Brian.
I think Mike was ahead of me, but I'll just, I definitely follow all your reasonings for not using the well-known location, but I get real worried about this basically an open vector for anyone on the unauthenticated public internet to just say, hey, go grab this document from this arbitrary location. So at a very minimum, there needs to be some real serious guidance on the server side about how you can practice that safely. And I think maybe to David's point previously, like the relationship, figuring out who this client is and whether you trust them, that those aren't the same top level domain, feels like it maybe undermines any potential establishment of trust that you might otherwise get in a scheme like this, where you go out, validate the TLS host name and associate that with the client, the redirect URIs. I haven't quite thought through that, but maybe you have, and I'm.
There's two different concerns. One concern is whether or not the URLs in here are on the same host as the client ID document.
Yep.
And that one, like we could say that they have to all be on the same host, and that is a reasonable conclusion to requirement to make for those reasons.
Maybe.
And that would solve several problems. The one that you can't really get around is the fact that anybody can stand up a web server on any domain and use it in any request, because that is how this is supposed to work. So like that is by design, right?
For sure, but it's like the correlation between where that web server is, its TLS certificate, and some oriented trust in that, I think is like, you want to have that design, but I think you want to maintain that correlation. So I can't stand up something that points to your servers or vice versa.
Oh yeah, I mean that's the reason that the client ID value has to be inside the document, right? And that's what protected resource metadata does, and authorization server metadata.
Yeah.
Same thing, right? So yeah, like I should not be able to create a document that has these values that lives on some other URL that works, which the way to prevent that is to make a requirement that all the host names match of any of the values in it, right? Which is kind of the best we can do in this world, where it's designed to be open. It's designed to have anybody show up with a new client that is unknown to any of the authorization servers.
Yeah, I think I agree with that. But then there's also the issue of you want to make sure you also at least have some guardrails about someone showing up with a pointer to their 800 gigabyte
For sure.
virus infected
Yeah.
document,
I mean,
and just having the servers download those repeatedly and things that
Yeah.
may not be
we,
obvious.
We have a handful of that kind of stuff in there already. There's
Okay.
like notes about don't fetch localhost URLs, put some limit on the size of document, like ignore it if it's not JSON, blah, blah, blah. That stuff's pretty straightforward. I'm not really worried about that. The other interesting one that there is a good discussion going on in this repo now is about development clients. What do you do when your authorization server is your development server on your local laptop and your client is local? Also, now you actually do need localhost URLs to work, so there needs to be some sort of flag for like, okay, we're turning on local development mode, so it's okay to accept,
Allowance.
Anyway, there's a discussion going on about that right now. It's I didn't put the issue number in here, but you can go find it on the repo.
Okay, you want to take more comments here, Michael?
How are we on time?
We have time.
Hi, Mike Barak here. I put a few links in the chat. Ori at some point dropped up some metadata discovery stuff that was, I mean, it was a typical Ori weekend project. So he thought through it a little bit, and there's some pages up there in Spice on that topic specifically. This is very closely related to a lot of things we've been dealing with in terms of system to system for supply chain use cases and traceability credentials. And eventually I'll be able to process things at the same time, but I'm not there yet. But yeah, it's very similar to use cases we have in practice where we're having multiple parties exchanging credentials and need to discover where am I going for this endpoint to go that, that conforms to such and such API definition. How do I make sure that's digitally signed, et cetera? We've utilized DidWeb for that pretty extensively. However, that obviously has problems, right? As an editor of that draft that's been sitting there forever, whatever. It's got issues, right? But some of those issues have been addressed and looked at by other folks, right? So I did put a link out to someone that has, I think from our local current jurisdiction's government that actually thought through like, how do we bind this stuff back into DNSSEC and stuff like that so that you can get around some of these security concerns. So I don't think there's a perfect solution to this yet, but it is certainly a real problem. I think the furthest ahead that I've seen is some of the work that's starting maybe in Spice, and we'll find out on Thursday on that. So rather than duplicating efforts, maybe we could just consolidate and share resources and not beat each other over the head and have three things defining the same thing and a bunch of arguments over it.
Justin Richer. So I haven't had a chance to read this draft yet, so here are my opinions on it.
Of course.
Yeah, no, for real though. I think that the trust model is very much in line with dynamic registration. If it's meant for an open connection, that part's clear, and that's the type of thing that you can put appropriate guardrails around. Plus SSRF, because this is a huge SSRF thing. But I mean, that there's. Yeah, it sounds like there's already some stuff in the doc about that, and that's great. I also, however, wanted to point out there's a bunch of sort of half-baked prior art in this area, not least of which is something that John and I wrote 10 years ago, which was basically how do you cram all of that nonsense into a Jose object as the client ID. It's called structured client IDs or something like that.
I ran into that at some point.
Yeah. And so it never went anywhere. I don't think anybody ever actually implemented it, but it was a similar idea of making the client ID semantically significant. With that in mind, OpenID Federation is doing a similar thing with making the client ID semantically significant with automated registrations, and there's a client ID type proposal that Torsten's brought up. All of this is going to have to work together if it's going to work at all, because otherwise this is we're going to have multiple semantic layers on top of a field that was intended to be an opaque value decided by the authorization server, and nobody else got to have a say in what was in it. So a lot of foot guns here.
Christina.
To add more to that, so I think I just wanted to offer some real life implementation experience we have from the OpenID for verifiable credentials world, because that's where we had the exactly same problem. That was why Tobias Torsten and I brought this, like similar proposal, to IETF, like few IETFs back. So basically what we did is we introduced the client ID scheme parameter, which did give a semantic meaning to the client ID that is being brought by the clients that have not been previously registered. And few insights we learned is, so when I completely agree with the statements that, like, based on what do you trust this, right? Like the redirect URI, the logos, whatnot. And I think you're saying it's web, it's hosted at the endpoint, but you still kind of need to establish trust behind it. One way to do it to have a list of trusted URLs, but then, how is it different kind of from pre-registering out of band? And what we've seen people do is the mechanism is usually used with a signed request. So you signed request with a key that's obtainable using multiple mechanisms, OpenID Federation being one of them. And you can go up to the root of trust that you actually trust. So what you need to know is that root of trust that you can go up to once you can validate the signature on the request. So maybe that kind of mechanism could be helpful here as well. Having said that, back then when we brought it to IETF, there was not much appetite. If there's appetite now to progress this, we'd absolutely like to see alignment between what we've been pioneering, because when the client ID is URI, there might be multiple ways to resolve it to something like this, right? Like there could be OpenID Federation. It could be an X509 related mechanism where the definition is X5, this URI, is the same as SAN-DNS in the X509 cert, or, things like that, or even unknown stuff. So, and I'm sorry, I'm trying to organize as I speak, but another thing is, so I said we introduced the idea of client ID schemes, but then from a security purposes, whenever that client ID gets passed throughout the flow, because there were multiple mechanisms how URIs could be resolved, we realized that, or our favorite Dr. Daniel Fett pointed out, that you have to kind of combine client ID with the scheme to be able to securely identify and trace that owner of that particular client ID. So, well, we don't have a rough consensus yet, so I can't speak for the entire working group, but what seems to be the direction is to, yes, namespace the client IDs and the scheme in front, which sounds like something you also considered. So long story short, we do have some specific implementation experience that if this work progresses, I would really like to be incorporated so that things don't, go further apart.
Awesome.
That was a lot. I do want to just point out that by definition in this deployment, the Federation trust root does not work, cannot use that. There is by definition no single authority that governs who's allowed to be a client in this world. The closest we have to that is DNS. So we can't just use OpenID Federation for this.
I don't think I'll ever be the person saying just use OpenID Federation. It doesn't work that way, yeah.
But yeah, I just wanted to point that out. Now I can't remember the other.
Yeah. Okay. So, yeah, she threw lots of things at you for now.
Yeah.
So, Ori, do you want to go ask your question or comment?
So you had a slide where you had the well-known with the sort of multi-tenant structural identifier thing in it. Yeah. So there's other OAuth documents that have a similar structure. Maybe it was VC SD JWT or something like that, where you're trying to discover multiple unique identifiers on this well-known origin or domain thing. And you had mentioned keys at some point in here, and I think in that document they are disclosing keys uniquely in each of those URLs. Can you just repeat the thing you said about, does this fit together with those keys? Is this like a universal solution that, you know, this JSON object could have keys in it and then they could just use this thing too? Like, I'm trying to like see the relationship between this and that. And I have a second question, which is about security implications of this, which I'd probably just ask you offline.
Sure. Yeah. So what I was getting at is that because this is all the parameters in this document are the ones in the client metadata IANA registry. One of those is JWKS URI. So you could put the JWKS URI in this metadata document in order to advertise public keys of the client. Before we run out of time, I do want to go to my very last slide, which is to show how much this is actually already getting built out. There's a handful of live implementations of this, only some of which I wrote myself. There's some in progress work. The Blue Sky folks were actually at the hackathon here yesterday, and their demo will be this evening, I guess. I don't know how it turned out yet, but they were working on, this is incorporated into their OAuth profile. There's a lot of interest in this, in using this as well. And I think one of the reasons for it and for the relatively quick adoption of this in implementations is because it is extremely narrowly specified. It is saying we're using HTTPS, we're using DNS, we're using all the client ID metadata that's already in IANA. It is a very narrowly defined profile of this, and it's not meant to solve every problem. It's also very unlikely that a deployment that uses this would also implement other more typical OAuth as well of requiring pre-registration, because it's for a very unique deployment of OAuth. So that is all.
Okay, thanks. You wanna ask a question?
Yes, clearly I see a lot of interest, but I also see gigantic security holes in there, which sort of scares me a little bit when people start implementing sort of a early version and glance over the security aspects, because some of those security aspects have also been discussed in the dynamic client registration, which there we added mechanisms like the software statement and so on to deal with some of those challenges. So yeah, looking forward to see a discussion about how to deal with some of them.
Yep.
Okay, thanks, Aaron. Peter. You want me to pass? Got it? Go ahead.
Okay. Good afternoon, everyone. My name is Peter Kasselman. I am going to talk for a moment around an idea called encrypted authorized response, and really just hoping to float an idea and maybe get some feedback based on experience in this room. So let's talk a little bit about the challenge or the problem, right? So authorization code flow with Pixie is great. It avoids all the challenges with implicit grant flow. It prevents user agents from accessing tokens and protects against authorization code and CSRF attacks if you use Pixie. But it does have this other challenge, which is it does require this extra round trip. And this has an impact sort of on costs, especially at scale, and also user experience with latency and page load times and things like that. And so one idea is, well, what if we could just encrypt the authorized response? So in this sort of very simplistically, could the client generate an ephemeral key? Could it send that key material along to the authorization server as part of the authorization request, and then have the authorization server return the encrypted response to the client? And then the client can decrypt the authorization response with this ephemeral key and have access to the access tokens or other tokens. So that's kind of the idea. And I'm kind of curious, first of all, if folks have thought about this or if they've tried this or in the process of developing the authorization code flow, whether this is something that has come up. So that's kind of the hope to get some feedback from, or if people have had experience with this and just want to come and chat to me about that, that would be great. I think looking at this, right, there's sort of a bunch of security questions that come up when we do something like this. So first of all, right, credential leakage, right? Would this give us a similar level of protection to what we get with the authorization code flow? Via browser history, right, again, similar level of protection or worse, better. See, Brian said it's going thumbs down. Around access token injection, right? Also central constraining, right? How would you possibly do central constraining these tokens? And again, see Brian taking a deep breath there and a big smile. And then also around redirect URI validation and also refresh tokens, right? Would you even consider returning a refresh token? So that's kind of some of things to, some questions that come up, but kind of curious to see, because this feels like an obvious thing that people might have tried or looked at or analyzed over the last couple of years, and really just looking for some feedback or insights from experience with this.
Okay, Philip.
Hi everyone, this is Philip Skokan from OAUTH. Hi Peter, nice to see you remotely. Do you envision this as an extension to the authorization response then, like to the authorization endpoint response? So this still travels in redirect back to the client, and the extra round trip that you want to avoid is the call to the token endpoint?
Yes, yes.
Okay, so this is JARM. This is something we developed in the FAPI working group, where we already have a JWT authorization response mode, which you can also use to encrypt the response. And effectively, you're asking for, if you're talking about getting the access token as well, you're asking for an implicit response using the JARM response mode.
Okay, thanks, Philip. I'll definitely go have a look at that. Thank you.
Yep, you're welcome.
Brian.
Philip is right as usual, except one major difference from JARM is it uses pre-registered keys for the encryption. It sounded like you were talking about ephemeral keys, which is maybe one difference, but it's definitely worth looking at JARM. And analyzed is too strong of a word, but I have looked at a lot of this stuff and some of these attacks in the context of FAPI, which is where the JARM specification was developed. And my very naive analysis is it doesn't actually get you a lot of the security problems that you might want to get from here. So yeah, sorry to say that. A lot more thinking probably needs to be done, but there's a lot of subtle bad things that don't quite work the way you'd hope.
Yep. Thanks, Brian. Appreciate that. Yep, so thanks for that feedback. I was also curious, right, maybe there's been some formal analysis on this. I was hoping Daniel would be here, but I'll probably try and catch him a different time. And then I guess in terms of next steps, maybe I might write this up as an individual draft just to get a little bit more of the detail fleshed out. But thanks a lot for the references back to JARM. Brian, thank you. And Philip.
Okay, awesome.
Thank you.
Thanks, Peter. There. Yeah, put it there. Yeah. Okay.
Any other issue?
Any other business? Yeah, we have 6 minutes.
So if you don't say anything, we will sit here, stare at each other at 6 minutes. We won't let you out.
Okay.
Now the exam.
Yeah. Thank you all. See you tomorrow. That's good.
Yeah. Good stuff. We should find some time to